So, okay, Gitesh is also here. Right, yeah. Sanvita is here as well. Okay, Advik, Arnav, guys, stop playing with emojis. Stop playing with AI. Not needed in the middle of the class. So, who all have joined the middle in the meantime? So I see Thanu, I see Vivan, Sanvita, Sanvi, Pranav, Kaushik, Lachita, Gitesh, Deekshita, Advik, Ashrit, and Arav. All right, let's start. So, do you guys remember what we are trying to learn today? Vasundhara is also here. Yeah, Arav. What do you remember?
We learned compound interest, and we also reviewed a few questions from the homework that didn't require log.
So we're not talking about logs right now. We talked about compound interest in the class yesterday, and today we are going back to. There was one concept on Pythagorean theorem that we wanted to cover. One of you told that Pythagorean theorem you would want to cover one more time, so that's what we'll cover today. Applying Pythagorean theorem and then also recalling how the Pythagorean theorem was derived. So these two things that we will do today. So first we will try to understand or recall how do you derive a Pythagorean theorem, and then how do you use it for solving problems applying Pythagorean theorem. Yeah? So now a quick question to everybody. Do you guys know what is the Pythagorean theorem? Yeah, tell me, Vasundhara. You have to tell me. A square plus B square equal to C square. Little more context to it. Who can add? Yeah, Advik.
It's like the baseline or like the side. B is the bottom and C is the hypotenuse or something.
Okay. What do you want to add, Arav?
So basically, so the whole play works where the hypotenuse equals to both of the sides rectangularly, having rectangles matching the sides. That equals C square equals the hypotenuse, and both sides, A square plus B square, both equal those two other sides that match with the hypotenuse. And if you want to do a complex, you can also take away the square.
Complex things, I'm very scared of complex things. We'll keep it simple. Okay. Kaushik, do you want to share what is your understanding of Pythagorean theorem? Why do we use Pythagorean theorem? When do we use Pythagorean theorem? Or what exactly is Pythagorean theorem?
I haven't learned about that yet.
Oh, you have not learned about that yet. Okay.
Yeah.
Okay. Cool. So, Advik, you have done your bit. Okay. I'll have to give chance to everybody else in the class. Otherwise, only one or two people will talk. Anybody else? Apart from Advik, Arav, Vasundhara, Deekshita.
To find like a missing side.
It helps you find the missing sides. So, if I start from ground zero, everybody knows what is this called? No, Arav, hands down. I'll not let you guys answer those easy questions. So everybody knows this is a right angle triangle, meaning a triangle which has one angle is 90 degree. So Pythagorean theorem, again before I go to Pythagorean theorem, what are the key properties? The longest side of the right angle triangle, which is opposite to 90 degree, is called hypotenuse. This is the adjacent side. Sorry, this is called the base, it seems like this is standing on this triangle is standing on this base, and this is called the adjacent side. Or you, in mathematical terms, you say this is A adjacent, this is the base, and instead of hypotenuse you call it C. So what Pythagorean theorem says is C squared equal to A squared plus B squared. And this is like a universal rule that we learn for ourselves. Meaning, if you have a right angle triangle, the square of the two sides making that right angle. See, this side and this side together is making this angle 90 degree. So the square of these two sides is equal to the hypotenuse or the largest side of the right angle triangle. That would be the what do you call the theoretical definition of a Pythagorean theorem. You know that, right? Now, so Kaushik, my suggestion or request to you would be, don't worry about taking notes, because whatever we do in the class, that is getting recorded, and I upload the video of that class for you guys to consume. Okay? So you will always have everything that is done in the class as in the form of a recording that you can watch anytime and you feel like. Okay. And that's done with the purpose that so that you guys can focus on grasping the concept rather than being busy taking notes. Yep. All right. So, and again, my request to you all would be, stop playing with emojis. That's not fun. You guys are big enough to know what is right versus what is not. It will be bad on my part if I have to keep on saying that same thing again and again. Okay? Stop playing with emojis, no texting, no cause of distractions. Okay. So, Sanvita, Vibhuvan, Bivan, Tanu, everybody with me, right? Kaushik? As far as the definition, understanding of the Pythagorean theorem goes, that says, in a right angle triangle, the two sides that is making the right angle on the 90 degree, the square of the two sides is equal to, the sum of the square of the two sides is equal to the square of the longest side or the hypotenuse. That is Pythagorean theorem. So tomorrow, as Dikshita said, that you can find out the value of the missing side. If I say I have a right angle triangle where this side is 5, this side is 12, find out the length of the hypotenuse, you can apply this theorem. You square this plus square this will be equal to square of this. You can find it out. That is the main use of this. Arab, do I need any information from you right now, or do you have any question right now?
I have a question. So at the end part of the system, when it comes to square root, can we use the calculator for this theorem?
We are running a 100-meter race. You are competing for a marathon. Hold it there. See, I would always see, I keep stopping you from going way too far, because that's what happens if we keep covering the smaller goals one after another. That helps us achieve the bigger goal. Don't try achieving the bigger goal in one go. That is not fun. Okay? Let's not do that. Simple thing. Don't go way too far. I'm saying that if we get this concept deep rooted in our mind, that why do we need Pythagorean theorem? How does it help? What is the purpose of this? If you know this, if you learn this concept, if this gets stuck in your head, then dealing with it with different flavors would not be difficult. Okay? So don't try mixing too many things at the same time. That might get you confused, which is not a good thing for any student. Okay? Yadrik?
Isn't there a subject based on this?
So there is a subject based on that is called trigonometry, and that deals with a right angle triangle, but that is little too early for you guys. Hold it for some more time. Yeah? But for everybody, this is now the basic premise of understanding why do we need a Pythagorean theorem. Yeah? So this is the Pythagorean theorem. Now you will say that a teacher comes from nowhere and says that this is the formula, memorize it. Why? A teacher is not supposed to be so authoritative, right? At least a maths teacher. A maths teacher's job is to make sure that he or she makes you understand the concept, underlying concept behind anything, any formula that you deal with. There could be some formulas that we'll be able to kind of derive now, and there'll be some formulas that we will learn now but we'll derive later because that needs little more understanding of the subject. But this one we can probably use. So whoever has attended this class before, where I have proved the Pythagorean theorem, how it is derived, does anybody recall what was the key approach, what was the key concept that we took into account? To prove a Pythagorean theorem, what was the key concept that was used for proving it? Anybody remembers? And keep it to the point, don't tell me story. Yeah, let's see. Yeah, Rav.
So basically, when you see the triangle or the hypotenuse has an equal rectangle with each of them. So it means that if the hypotenuse is missing, we can still use the other length to match the rectangles at a
No. So you are telling me how do you use Pythagorean theorem for solving problems? I'm saying we have to also figure out or recall how the Pythagorean theorem came into existence itself. What is the concept that has derived or given birth to this Pythagorean theorem? That is my question. Yes, Sarvita.
We used cis, cos, and tan.
No. Yadvik.
Algorithm.
Say that again.
Algorithm.
No, you are giving a different name to this guy altogether. Unfortunately, this gentleman has given this formula and died few decades ago, and you are changing his name now. It's Pythagoras. Pythagoras is the name of the person, and that's why he's the one who gave who kind of derived this theorem. That's why it's called Pythagoras theorem or Pythagorean theorem. Now, what I was trying to learn from you guys is there's an underlying concept behind how this theorem is derived. So now let's look at it. These are two triangles, okay? I call them similar triangles. Do you know why? If this triangle has one angle, let's say A, and this is also A, this angle is B, this angle is also B, this angle is C, and this angle is obviously C. So the two triangles have matching angles, but the length of the sides are not same, right? As you can see, this side is not equal to this side, correct? This side is not equal to this side. This side is not equal to this side. Everybody plays with phone, right, Lokshita? You guys have exposure to phone. There's something called zoom in, zoom out. You take a picture, you zoom in, the picture becomes bigger. You zoom out, becomes smaller, but the shape remains same. You will just see your face becoming big or small in the picture by zooming in, zooming out, right? Right, Gitesh? Agree? So this is zoom in, zoom out. Here you are zooming in. The same triangle is becoming bigger, but the angle remains the same. You are zooming out, this is becoming small. When you zoom out, you get this. Your angle remains the same, but the size becomes smaller. Okay? So this kind of scenario is called, when you relate that with a triangle, with two triangles, these are called similar triangles, meaning when the angles are matching, each and every angle has a corresponding matching angle, but the sides are of different length. These are called similar triangles. Okay? Is everybody with me? So, when you talk about two triangles as similar triangles, you are essentially saying there are two triangles where the angles are matching but the sides are of different length. Or in more practical or relatable scenario, you are talking about zoom in, zoom out scenario that you do in a phone. Same picture, similar properties, just become small or big. Yeah? Is everybody able to relate? Now, so this is the concept which says if you have similar triangles, let's say this angle is A, the side opposite to that is A. This angle is B, side opposite to that I am calling as capital B. This angle is C, side opposite to that is capital C. Here this angle is A, I am saying this as A1. This is angle B, side opposite to that is B1. This is C, side opposite to that is C1. So when you have two similar triangles, the ratios of the sides are equal. What does it mean? Ratio of the sides meaning, let's say if you look at angle A, this is angle A here, this is angle A here. Side opposite to that, A, and here same angle opposite side, A1, will be equal to B by B1, will be equal to C by C1. Yeah, Rav.
When they say they have to equal, does that contribute to it should equal 180?
I did not say that. There is no triangle in the world which never adds up to 180 degree. You cannot imagine a triangle ever which doesn't sum up to 180 degree. Okay? So that's a universal truth. Like your name is Arab Puri, that can never change. My name is Virendra Kumar, will never change. This has become universal truth for the rest of our life. Okay? Same way, any triangle, there will not exist any triangle which will have sum of angles different from 180 degree. It has to be 180 degree by default. What I'm saying here is, if you have two similar triangles, their sides will be in the same ratio. When I say sides, I'm saying sides opposite to the matching angles. This angle is matching, so side opposite to that. So this divided by this. This angle is matching, so side opposite to that is B divided by B1. This angle and this angle are matching, side opposite to that are C and C1. If you have two triangles which are similar, this ratio will follow. Are you guys able to relate that first?
Yes.
Yeah? So Kaushik, Vasundhara,
Yeah.
everybody?
Yeah.
Roshita, everybody? So simple thing. Just only takeaway for you guys is that when you have two similar triangles, meaning two triangles with matching angles, sides are different, okay? Then their corresponding sides will be in the same proportion. Now, how do you find the sides? You always refer to the angle and the side opposite to that. Matching angle, opposite sides, same ratio. Matching angle, opposite sides, same ratio. Matching angle, opposite sides, same ratio. Okay? Does it go down well so far? Okay. Vivan with me? Vivan?
Yeah.
Sanvi? Sanvita?
Yeah.
So remember one thing. This is similar triangle. When you have two triangles matching all the properties, those are called congruent. Here we are not talking about congruence. We are talking about similar triangles. Meaning they are zoom in, zoom out scenario. Okay. When you have zoomed in to make it big, you have zoomed out to make it small. So the angles are same, the shape is same, just it became big or small. Okay. Like these are similar triangles probably. All the angles are matching, but we have zoomed out to make it small. Okay. If my triangle will never be similar to a circle. Meaning, no matter how great my phone is, if I zoom in, zoom out on a triangle, it will never look like a circle. Right? It will always look like a triangle. So similarity holds true in the case of similar shapes. Okay? It doesn't change. Now, let's keep this understanding in our mind for now, and let's use let's see how we can use this concept for proving the Pythagorean theorem. This is my right angle triangle ABC. This is 90 degree. What I will do is, from here I will draw up a perpendicular. Oops, this doesn't look perpendicular. I will draw up a perpendicular from here to the opposite side. This meets at D. Meaning this angle is 90 degree and this angle is 90 degree. Okay. Now I'm talking about triangle ABD and triangle ABC. Meaning triangle ABD, meaning this highlighted one, and then the bigger triangle ABC. I'm saying these two triangles are similar. Do you guys agree? Why? You don't have to agree just because I'm smiling and saying you have to. Look at this. If you look at this big triangle, you have this angle and 90 degree. Correct? Yeah, Gitesh. Gitesh, you're talking on mute. I cannot hear you. You're still talking on mute. You have to take out your headphone. That might work.
Hello?
Yeah, I can hear you now.
Okay. So if you zoom in more, if you draw the same thing, but if you draw the exact same triangle with the exact same angles on another, over somewhere on the board, and then zoom in, and then it's the same thing, zoomed out.
See, that is one way of doing it, but I have another mathematical way of proving it also. Let's see what Arav has to say. Arav, you have 30 seconds. Go, be quick.
So, doesn't the a square, so if you look at it, a square plus b square has to be
Hold it.
equal.
Hold it. No, hold it. That's what we are trying to prove. Our goal is to prove if this is A, this is B, and this is C. I'm trying to prove A square plus B square plus equal to C square. So don't go there. Don't use Pythagorean theorem. Yeah. Okay. I'm saying I have given you two triangles ABD, the one that I have shaded right now, and triangle ABC. I'm saying these two are similar. You have to just answer me why you think they are similar. Yeah, Kaushik.
Can I use the restroom real quick?
Yes, please.
Okay.
I'm saying these two triangles are similar. When the triangles will be similar, when the angles are matching. That's the only thing. Let's look at these two triangles, okay? Let me make it a little easy looking for you guys. I'll put triangle ABD here and triangle ABC here, okay? Now let's look at what are the angles these two triangles have. The triangle ABC has what angle? Angle ABC, which is equal to 90 degree. That's what we know, ABC, this one. Then it has triangle ACB. Come on. My bad. ABC is here. So triangle ABC, angle ABC, which is 90 degree. Then angle ACB. Then angle BAC. So BAC is this angle, ACB is this angle and ABC is this angle. Okay, I put the three angles here. Now look at triangle ABD, this small triangle. What are the angles it has? It has angle BAD, then it has angle ADB, which is 90 degree, ADB which is 90 degree, and then angle ABD. Now if you look at these two, you have one angle this and angle this matching, both are 90 degree. Agreed? Now BAD and BAC and BAC are the same angle. So this angle and this angle are same. Yeah? BAD and BAC, same angle. I'm just stretching this line a little bit further. Yeah? Or you can visually see it also. This angle is common in this triangle and this triangle both. Yeah? Yeah? Sure? Who all is with me and who all are not?
I understand, sir.
You understand? Sanvita, you got it?
I understand, sir.
Kaushik? Kaushik is not. You understand? So again, look at it. I'm just saying I took a right angle triangle. From this corner I have drawn a perpendicular on this one, which splits this into this triangle and this triangle. So basically this larger triangle got split into two right angle triangles. Now I'm picking the first right angle triangle, which is ABD, and I'm comparing that with the larger triangle. And what do I see is these two are this small triangle is similar to this large triangle. How? Because my angle ADB is 90 degree and angle ABC is 90 degree. So these two angles are matching. Then angle BAD and BAC both are common in both the triangles, that is matching. If two angles of a triangle match, if two angles of two triangles match, the third angle doesn't have a choice for not matching, because sum of three angles will be 180 degree. If two angles have matched between two triangles, the third has to match. No choice. Agreed or no? Kaushik, do you agree?
Yeah.
Advik, Sanvita, Lakshita, Bhuvan, everybody agree? So if you have two triangles and two angles have matched, third angle will match, because sum of the three angles is 180 degree. That is a universal truth. So here what we saw is these two triangles are similar to each other. So when they are similar, what does it mean? Meaning their sides will be in the same ratio. Arav, no playing with emoji. Did I not say that in the beginning of the class? All of you, I said no playing with emoji in the beginning of the class. I would sound very stupid if I keep on repeating myself, isn't it? Don't do that, please. Now, when two triangles, when I found that triangle ABC and ABD, meaning this small triangle and this large triangle are similar, that means their sides will be in the same proportion. What does it mean? It means, let's look at the matching angle. This angle is matching with this angle now, because this is 90 degree, this is common, so this angle is matching with this angle. Meaning angle ABD and angle BCA or BCA, yeah, ACB. These two are matching. So side opposite to that will match, as will be in the same ratio. ABD by ACB. ABD by ACB. So ABD is this side opposite to that is AD. AD and this angle is this one ACB. So side opposite to that is AB. This will be equal to the second angle. Let's pick up this angle BAD. So this BAD and BAC are same. So that means side opposite to this in small triangle is this one BD divided by BC. So again, you might be finding it little complicated, but simple thing is the thumb rule is when you have two similar triangles, you have to look at the opposite sides opposite to the matching angles, and the ratio will match. That's all. Look at two matching angles and find out the ratio. Similarly, now this one we got, and if you will be equal to the third angle is 90 degrees. So this is, when you look at this 90 degree, side opposite to that is AC. No, I'll pick the smaller angle for triangle first. So this is AB divided by AC. So what I will do is I'll pick this and this. So AD by AB equal to AB by AC. That means AD by AB equal to AB by AC. That makes it AB squared equal to AC into AD. So again, this might be looking confusing, but if you look at it in a simpler way, I had a right angle triangle. I have drawn a perpendicular from here to here, which split this into two right angle triangles, this one and this one. I am picking this triangle and comparing that with the larger triangle, and we found that these two are similar. So when they are similar, their sides will be in the same ratio. So I'm just comparing the equal angles in both the triangles, making sure that my numerator is always the side coming from the smaller triangle and my denominator is coming from the bigger triangle. And then from that I picked up these two combination. So AD by AB equal to BD by BC equal to AB by AC. I picked up this one and this one so that I can get AB into AB in one side. That gives me AB square. I got AB square equal to AC into AD. Okay, this is with the first triangle. Who all are confused? Everybody. It's okay. It's okay to be confused. I will repeat myself from beginning to end when we do that, and then you'll be able to relate. And then you anyways have the video for your reference as well. That will clarify it. And trust me, in none of the examination hall or none of the tests you will be asked to prove the Pythagorean theorem. We're just trying to learn the concept. Yeah, everyone.
Right, sir, what is the 3-4-5 rule?
3-4-5 rule. 3-4-5 is a subset of this rule actually. These are different combinations. 3-4-5, 5-12-13. And you can go in the multiples of that actually. Okay. So we'll come to that. Now we looked at the first small triangle and the bigger triangle, and we found this AB square equal to AC into AD. I'm just keeping it there. Now let's look at the second triangle. Triangle BDC and triangle, bigger triangle ABC. I'm saying these two are also similar. Can you agree? If I'm saying this triangle and this large triangle are similar. Why? You have one angle which is anyways common between this small triangle and the big triangle. You have 190 degree and this has 190 degree. So that is matching. So if you want to put it here, right, you will say that this is a common angle. And then you have 190 degree in the large triangle and 190 degree in the small triangle. So two angles have matched. So third angle has to match. No choice. Yeah? No? Dikshita's Pranav, Lakshita, Kaushik. Anybody has any doubt?
No, uncle.
No? Okay. Yeah. So from this we find that these two triangles also. So let me put the angles, okay? So let's see angle. If I'm looking at small triangle BDC, angle BDC is 90 degree, and the matching angle in the last triangle is angle ABC. Yeah, these two angles are matched. Now this angle in this small triangle and the big triangle are common. So angle BCD, angle BCA. These two are again equal. So I'm putting the equal angles together. So you see the first angle is matching 90-90, second angle is common anyways, and obviously the third angle will be angle in the small triangle. You should see that will be this one, that will be DBC, this angle, and angle this one BAC. And these two will be also equal because you have two angles which have already matched, so third angle has to match. So when you have these angles matching, now look at this. If you look at these two angles, okay, let's put the side opposite to that angle right beneath, right underneath that angle BDC. If you're looking at the small triangle BDC, this is the side, this is the angle. Side opposite to that is this one BC. I'm putting it here. Similarly, if you look at second angle, which is ABC, 90 degree, this one ABC. In the larger triangle, side opposite to this will be AC. This is AC. Now look at angle BCD. BCD. In the small triangle, the side opposite to that is what? This one, BD. I'll put BD here. Now BCA. BCA. In the large triangle, side opposite to this will be this one, AB. I'm putting it here, AB. Now DBC. DBC. This is the angle. Side opposite to that is this part, which is D to C. I'll put a DC. This angle is BAC. BAC in the large triangle. Side opposite to that is this one, BC. So you got that. This angle and this angle are matching. Side opposite to that is this one in small triangle. Side opposite to this one is this one. This and this are same. Side opposite to this is BD. Side opposite to this is AB. Side opposite to this is this one. Side opposite to this is one. So we can just put the formula here. BC by AC. BC by AC will be equal to BD by AB will be equal to DC by BC. I think this was a better approach, right? When we put the matching angles together, you can relate it, and I am putting the opposite sides also against those angles, so that makes it look easier to relate. Now you can say, okay, since these angles are matching, side opposite to that will be in the same ratio. These two are matching, side opposite to that, the same ratio. These two angles are matching, the same ratio. Now, here, what will you do? You will pick this and you'll pick you'll pick this and this. So what happens is these two, so you'll say BC by AC equal to DC by BC, and hence you multiply this way. So BC into BC, BC squared equal to AC times DC. Somebody has raised hand? No? Yeah, Raf?
Will you find the square root of BC eventually?
Why? No, so Adam, my sincere request to you would be, hold it for a little bit till we come to a conclusion. Otherwise, we will just have a rerouting of the whole thing and we'll go in a wrong direction. Did I talk about square root at all? Then why are we going there? You can learn one thing at a time. When you're learning math, you can learn math. When you're learning science, you'll learn science. You cannot learn math and science together. So right now we're not talking about square root, so I'll say don't go in that direction because that'll make you overthink. So look at this. What we got was this. We got two values. AB square equal to AC into AD, and we got DC square equal to AC into DC. And again, why? You will say why? How? Let's do a repeat. We had a right angle triangle. We drew a perpendicular from here to the opposite side that met at a point D, and that split this right angle triangle into two right angle triangles. One was ABD and other one was this one. So we took this right angle triangle and compared that with the larger triangle. We found that this angle is anyways common. This angle is 90 degree and matching. So we found these two triangles similar to each other. And when we put that, I mean, this we are looking at the second right angle. Okay, or let's do it. So we drew a perpendicular, split into two parts. When you look at this right angle triangle with the larger triangle, you found that you have one angle 90 degree, one angle common, like in this triangle and the larger triangle, this angle was common in both of them, and the third angle has to anyways match. So you found that these two triangles are similar. So from this, you looked at every angle, matching angle and the opposite side, every matching angle, opposite side, you have just written it down. And the similar triangle says, when you have two triangles similar, their sides in the same proportion. So you put that from this by this will be equal to this by this will be equal to this by this. You did from this and you got this formula. Similarly, when you pick this triangle and the larger triangle and plot the same way, you got the formula from which you got this value. Now, when you add, you got AB square equal to AC into AD and you got DC square equal to this. Conceptually, if you see, you had a right angle triangle, you have drawn a perpendicular, you split that to two right angle triangles, you found this triangle similar to larger triangle, found the ratio, this triangle similar to larger triangle, found the ratio. And from that you got two formulas. Is that part understood so far or still getting you guys baffled? No? Okay. So now from this we got these two values. Now AB is nothing but my A. So I can say A square and this part is B. So BC is nothing but B. So if I add these two together, meaning A square plus B square, I get this value which is equal to AC into AD plus AC into DC. So now you see AC is common in both the terms. So you take AC out, you find AD plus DC. Now AD plus DC is nothing but AC here to here. So this becomes AC into AC. Now what is AC? AC is the C. So this becomes C into C, which is C square. So you got A square plus B square equal to C square. So the summary of this, how are we proving it? You don't have to memorize this. You don't have to struggle with this. Only thing that you have to keep in mind conceptually is that when you have two triangles similar, their sides are in the same proportion for the matching angle. Okay? Sides opposite to the matching angles are in the same proportion. That's the only thing that you have to remember. And then for proving this, we took a right angle triangle, drew a perpendicular, got one right angle triangle here, another right angle triangle here. This right angle triangle we found similar to the large triangle. Similarly, this small triangle we found similar to large triangle again. And when two triangles are similar, That means their opposite sides will be in the matching proportion. So from that we got this formula. That gives us the Pythagorean theorem's reason for this formula to be right, which is a square plus b square equal to c square. Yeah, Advik.
I have to remember all of those angles and all of the sides and all of that other stuff.
What is that?
We need to remember all of this.
Adam, if you stay stable, I'll be able to talk. Yeah, Advik.
Are we supposed to know like all the?
No, you don't really have to. No, you don't have to. See, even I did not remember. What I remembered was only the concept which says similar, when you have two similar triangles, their the sides applied to the matching angle will be in the same proportion. Okay, that's the property that I learned or remembered. And then when I put that in a right angle triangle, everything else was calculation. I did not memorize this. Okay, I did not memorize what I did for last 15 minutes. I just went step by step. I'm just comfortable, like Arav is comfortable dancing in a math class. I'm just comfortable doing math in a math class. Meaning, see, you have to be very comfortable doing sums, no matter whether you go wrong or right. Keep doing step by step. If you make a mistake, you learn from it. But if you are shy of doing calculation, that is when you don't get that comfort. Okay. So you guys can imagine when I was your age, how much practice I would have probably done. I mean, I never used to get tired. I'm sure you guys will do the same. Yeah, Rav.
Every time when you did math, did you also dance in your math class when you were that age?
Out of syllabus, we'll talk about it later. My only message to you guys is that when you are doing math, never get tired. Math is a game that you have to play without getting tired. So, all that I talked about in last 15-20 minutes, the only outcome from that was that if you have a right angle triangle, the gentleman named Pythagoras gave a Pythagorean theorem saying the two sides that make the right angle in a right angle triangle, the sum of the square of the two sides is equal to the square of the third side, which is opposite to the 90-degree angle or the hypotenuse. Okay? So, is that part understood by everybody so far? And if you ever get excited to understand or figure out how this Pythagorean theorem came into existence, I'm certainly not liking it. So, if you ever get excited to figure out how did Pythagoras theorem came into existence, if you want to prove that, if you want to flex about it in front of your friends, you can watch the video, you can do some practice, and you can say, hey, I can show you how the Pythagorean theorem was derived. That is something that you can do as an added advantage. But you don't really have to kind of memorize the steps, because nobody is going to ask you to prove it. In our case, I did schooling from India. So in our case, we had a situation where we had to prove Pythagorean theorem also in the exam. So that's how I have practiced this enough to be able to do that. But here I'm not seeing anybody having the need for doing it. Yeah, Rav.
How rare could like question be like asking to like prove it or like simplify it?
No proving, no simplifying it. It will be only to use it and apply it. But my job as a teacher is to make sure that you guys understand how it is derived, because otherwise I have very little to do. I can just give you guys formula and say apply it. Right? So when I'm teaching all these concepts, see, even if you forget Pythagorean theorem, one thing you will remember for sure, that is called the property of similar triangles, which not many people knows. Okay? I mean, you can just catch hold of anybody in your class and say, hey, do you know when you have two similar triangles, what happens mathematically? And see how many of them are able to give you answers. Okay? So, I mean, you can check that. I mean, I'm not joking. You can check with any of your friends in the class. Say, okay, fine. Do you know what is a similar triangle? First of all, 50% people would not even know about it. If they know, you can say, okay, fine. If you have two similar triangles, what happens? How do you use it? What is the relevance of having two similar triangles?
Basically, when you have two relevant triangles, you have to match them equally. That's all I have to say.
So you everybody got the concept, right? Now, let's do one sum. If I say that I have a right angle triangle and one side is 12 and then this side is 9. Find out this side. So who all are trying to solve it? Do it. I have a right angle triangle. This side is 12, this side is 9. And this is the right angle. So basically I'm asking you guys to find out the length of the hypotenuse. Yes, we want. Take a deep breath. Take a deep breath. Calm down. Yeah. Myra, you're doing it? Yeah. Yeah, Vivan, tell me. So Vivan is not telling. Okay. How about you, Advik?
15.
How much?
15.
Okay. How about you, Sanvi? Sanvi. Deekshita. Sanvita.
I got 15, sir.
You also got 15. How about you, Sanvita? How about you?
15. I got 15 too.
Okay. Arav?
I legendarily got 15. I cook so hard.
I don't know how to react. Okay, so let's come to serious business. I will tell you guys a trick. Now, if I had 3, 4, then this would have been again a square plus b square equal to c square. So 3 square plus 4 square equal to c square. So 3 square is 9, 4 square is 16. So this becomes c square equal to 25. C equal to 5. 3, 4, 5. This becomes yet one combination. So whenever, yeah, everyone. Everyone, you're saying something. I asked you to answer, you did not respond. So
Yeah.
yeah.
Yeah, I just accidentally clicked on mute. So like, this is basically what I used to get my answer, like the 3, 4, 5 rule.
Yeah. So that is 3, 4, 5 rule. Again, that is the basis is Pythagorean theorem. Where you know that okay, if it's 3 and 4, that becomes 5. So here I had given 9 and 12. What I did was I multiplied this by 3, multiplied this by 3. So this will also get multiplied by 3. And you don't really have to worry about it. So there are few combinations. I mean, obviously, the best method is to solve by applying Pythagorean theorem, a square plus b square equal to c square. But then there are few combinations that you will see more often. 3, 4, 5. Then 5, 12, 13. Okay. Then yeah. So let's say if you know these two combinations, right? What happens is you can look at the multiples of this. So 6, 8, 10 will be a combination. If you multiply this by 2, this will be a combination. If you see your sides are 6 and 8, you can by default say 10. If you multiply this by 3, so 9, 12 and 15 will be another combination. Like what Vivan was saying, 3, 4, 5 rule. Similarly, if you see this combination, 10, 24, 26, this would be one combination. So if you see any right angle triangle where it says one side is 24, one side is 26, find the third side. You can find it straight. Yeah? I mean, if your hypotenuse is 26 and one side is 24, you can find out the other side will be 10. Yeah, Shrit.
Can I use the bathroom?
Yes, please. So basically what I'm saying is, your base concept remains this. And these combinations are a derivative of this formula. Based on your practice, based on your experience, you might come across some more combinations. And then all the multiples of that will satisfy this. So you can literally toy on with that. And the more you practice, more combinations you find, you can apply those rules for finding out your answers much quickly. Yeah? So that brings us to the end of the class. Any questions that you guys have? See, Vivan is writing all the numbers that he is aware of. Yeah? So again, you can memorize them or you can derive them. I am very poor when it comes to memorizing things. That's why I always lean towards deriving it. Right? And what I don't practice, I don't preach. So that's why I don't ask you guys to memorize things.